Hello everyone, my name is Muhammad Adil Hakim, NPM 2231122, a student from Universitas Teknokrat Indonesia. On this occasion, I will discuss the maintenance of academic information systems based on the scope of infrastructure audit. This topic is very important because academic information systems are the heart of services in universities. Starting from student admissions, course registration, class schedules, grading, to the issuance of diplomas, everything relies on a stable and reliable system. In this presentation, I will cover 6 major aspects: the use of hardware, operating systems, file systems, database management, networking, and procurement. After that, I will conclude the discussion and provide recommendations. Let us begin with the first aspect. The first aspect is hardware usage. Hardware is the physical foundation that supports the academic information system. Without adequate servers, reliable client computers, and proper storage devices, the system can easily be disrupted. A common case is when the academic server has limited capacity. During peak times, such as course registration, the server slows down or even crashes because its specifications do not meet the number of users. The first aspect is hardware usage. Hardware is the physical foundation that supports the academic information system. Without adequate servers, reliable client computers, and proper storage devices, the system can easily be disrupted. A common case is when the academic server has limited capacity. During peak times, such as course registration, the server slows down or even crashes because its specifications do not meet the number of users. Many universities still use operating systems that are not updated regularly, making them vulnerable to cyber attacks. For example, there was a case where a university's academic server was hit by ransomware because its operating system had not been updated for years. As a result, academic data could not be accessed for several days. Good maintenance includes applying security patches regularly, using licensed software, and enforcing access control based on user roles. With this, the academic system becomes more secure and stable. Transition. After the operating system, let's move on to how data is stored, which is the file system. The file system determines how data is stored, structured, and accessed. The audit here ensures that data is organized, well-structured, and secure. Imagine if academic documents such as student grades, thesis data, and lecturer reports were stored without structure. Data retrieval would be very difficult, and the risk of data loss would be high. A common case is the loss of important data because no scheduled backups were in place. For instance, when a hard drive crashed, student records that had not been backed up were permanently lost. Maintenance includes setting up automated backups, managing access permissions, and implementing structured storage systems. This ensures academic data remains available even when unexpected problems occur. Transition. After discussing file systems, let's move on to the core of storage, which is database management. The database is the heart of academic information systems. All crucial information such as student profiles, lecturers, course schedules, and grades are stored here. Database audits focus on structure, security, and performance efficiency. A real case is when students complained about slow performance during course registration. An audit revealed that the database queries were not optimized, creating bottlenecks. Another issue is the absence of database backups, which could be disastrous if a system failure occurs. Maintenance includes optimizing queries, normalizing tables, encrypting sensitive data, setting up daily backups, and monitoring performance using specialized tools. With this, data becomes secure, fast to access, and consistent. Transition. A well-managed database will not be effective without reliable networking. Let's discuss the next aspect. Networking is the pathway that connects users to the academic information system. Network audits evaluate speed, security, and reliability. Without a stable network, students cannot register online, lecturers cannot input grades, and campus administration will be disrupted. A common case is when new student registration begins, and the network slows down due to insufficient bandwidth. This disrupts the registration process and creates frustration among users. Network maintenance includes monitoring traffic, implementing firewalls, using load balancing, and segmenting the network. Transition. After networking, the final but equally important aspect is procurement. Procurement is the process of acquiring both hardware and software. Audits in this area focus on transparency, suitability, and cost efficiency. Often, purchases are made without a proper needs analysis, resulting in mismatched or redundant equipment. For example, a university purchased a high-end server, but it turned out to be incompatible with their existing academic applications. Proper maintenance in procurement means regularly evaluating vendors, creating standardized procurement procedures, and involving end users in determining system needs. From these 6 aspects, we can conclude that maintaining an academic information system requires a holistic approach. Hardware must be reliable, operating systems must be secure, file systems must be organized, databases must be optimized, networks must be stable, and procurement must be well managed. Here are several recommendations. 1. Conduct infrastructure audits regularly. Point 2. Implement automated monitoring for servers, networks, and databases. Point 3. Upgrade server capacity according to the growth of users. Point 4. Always perform routine backups for both files and databases. Point 5. Involve stakeholders, including lecturers and students, in evaluating the system. By following these steps, academic information systems will not only be properly maintained but will also evolve in line with technological developments. That concludes my presentation on academic information system maintenance based on infrastructure audit scope. I hope this discussion provides useful insights and practical recommendations for improving academic services in higher education. Thank you for your attention, and see you next time. In addition to these 6 aspects, it is also important to highlight the interconnectedness among them. For example, reliable hardware alone will not guarantee system stability if the operating system is outdated or vulnerable. Similarly, even the best database management practices may fail if the network infrastructure is unstable or frequently disrupted. This shows that maintenance must be performed not in isolation, but in an integrated manner, where each component supports the other. Another crucial element is human resources. Many failures in maintaining academic information systems are not caused by technology itself, but by the lack of awareness, training, and discipline among users and administrators. For instance, administrators who delay applying security patches to operating systems may unknowingly expose the entire university system to cyber attacks. Likewise, lecturers or students who store sensitive academic data in unsecured personal devices may compromise the integrity of the database. Therefore, continuous training, awareness programs, and clear standard operating procedures are essential to complement the technical maintenance efforts. From the perspective of auditing, the role of an independent assessment cannot be overstated. Regular audits not only ensure compliance with standards and regulations but also help identify weaknesses that might otherwise go unnoticed. For example, an audit may reveal that the procurement team consistently purchases equipment from the same vendor without competitive bidding, leading to potential financial inefficiencies. Similarly, an audit may discover that network monitoring logs are not being reviewed, allowing small issues to escalate into major outages. Thus, audit activities function as a critical checkpoint to verify that maintenance is being carried out effectively and transparently. It is also valuable to connect these practices with international frameworks and standards. For instance, the IPL framework emphasizes structured processes for service management, including incident, problem, and change management. COBIT focuses on governance and control objectives, helping organizations align IT processes with business goals. Meanwhile, ISO 27001 provides guidelines for establishing and maintaining an information security management system. By aligning academic information system maintenance with such frameworks, universities can ensure not only technical reliability but also compliance with global best practices. Looking toward the future, academic information systems will face new challenges. The growing use of cloud computing, artificial intelligence, and big data in higher education will create new layers of complexity. For example, Cloud-based learning management systems must be maintained with attention to data privacy regulations, such as GDPR, while AI-powered applications for student analytics must be carefully managed to prevent algorithmic bias or misuse of personal data. This means that universities must be proactive, not reactive, in adapting their maintenance and audit practices to technological evolution. In conclusion, maintaining an academic information system based on the 6 audit infrastructure aspects: hardware, operating systems, file systems, database management, networks, and procurement, requires a comprehensive and forward-looking strategy. Technical reliability must be balanced with transparency, human resource competence, and adherence to global standards. By doing so, universities can ensure that their academic information systems not only support daily teaching and learning processes but also remain resilient against risks and adaptable to future developments. Ultimately, the goal of all these efforts is to ensure that technology continues to serve as an enabler of education, not a barrier. With proper maintenance, transparent auditing, and a commitment to continuous improvement, academic institutions will be able to provide reliable, secure, and innovative services to students, lecturers, and the wider academic community.